In this lesson, we're going to look at a specific characteristic of quadratic functions called roots. The root of a quadratic function is the points at which the parabola intersects with the x-axis. And your roots can also be called zeros. So if you're asked to find the zeros of a function, you're finding the roots. They're also called your solutions and your x-intercepts. So all of these words, roots, zeros, solutions, and x-intercepts are all synonyms for the same thing and what we're going to be talking about today. So depending on what your parabola looks like for your quadratic depends on how many solutions you have. So if your parabola has two solutions, it might look like this one, meaning it crosses your x-axis at 2 points. If it were to have one solution, it might look like this, crossing at only 1 point. It can also have no solutions, so if your parabola is set up higher on your y-axis, you can see that it doesn't cross your x-axis at all, so it has no solutions. And there's a few ways that you can find these solutions or these roots, and we're going to look at a couple of those ways. So first, we're going to find the solutions by graphing. So just like we did in our previous lesson, we're going to start by finding our axis of symmetry. Remember, that formula is x equals negative b over 2a. So we're going to be using that formula again. In this example, a is 1, b is 4, and c is negative 5. So when I put it into my axis of symmetry formula, I get x equals negative 4 over 2 times 1. Remember, when you're substituting in that a and b, make sure that you're putting it in parentheses. This would result in negative 4 over 2, and negative 4 divided by 2 is negative 2. So my axis of symmetry is negative 2. This will go in the middle of my table. And then we're going to fill in the rest with negative 1, 0, 1. And then above it, negative 3, negative 4, negative 5. Then remember, to get these y values, we're going to substitute each x value into my function. And we're going to use our calculator for this. Remember, you don't have to type the function over and over. You can simply go in and replace your x's with each x value. Also remember, as you're replacing it, to place that x in parentheses, especially if the x value is negative. So when you place those in, for negative 5, you should get 0. Negative 4 is negative 5. Negative 3 is negative 8. Negative 2 is negative 9. Negative 1 is negative 8. Remember, at that axis of symmetry, we should start working backwards. See that symmetrical values. Then, once we have all of our values, we can graph it. So I'm going to start by graphing my vertex, negative 2, negative 9. So over to the left 2, down 9. And then I'm going to start with the values above it. So negative 3, negative 8. Negative 4, negative 5. And negative 5, 0. And remember, it doesn't matter what order you graph these in. You're still going to get the same parabola. So working below my axis of symmetry or my vertex, negative 1, negative 8, 0, negative 5, and 1, 0. And then we'll connect them to see the entire graph. And then we're going to identify our solutions or our roots. So remember, those solutions are going to be where your parabola crosses your x-axis. And it does that at these two locations. I can also see on my table where my x value is 0. I also have, where my y value is 0, I have my solutions. Now, the way we write our solutions, so we can see that we have the two solutions and we know those ordered pairs. But the way that we want to write that is over here on the left, we're going to write x equals, and then we're going to use brackets. And then my first point on the left side, that is the point -5, 0. But we're only going to use the -5. And then my second point is 1, 0, and we're only going to use the 1. So what this is saying is that our parabola crosses the x-axis at -5 and at 1. So I know that this parabola has two solutions, two roots. Highlight number 2, and let's look at number 3. So we're going to do the same thing. We're going to use that formula, -b over 2a. And we know that a is -1, b is 2, and c is -3. We're going to plug in a and b into our formula. So that's x equals -2 over 2 times -1. And remembering to put -2 and -1 in parentheses. That's going to result in -2 over -2, which equals a +1. So our vertex is a +1, which will go in the middle of our table. And then filling in the rest, below it I have 2, 3, 4. And then above it I have 0, -1, -2. Then remember to get these y values, we're going to go to our calculator and we're going to substitute each x value into that function. And we're going to remember that we put each x value in parentheses when we substitute it in. When you substitute in -2, you should get -11. Replacing both x's with -1, we get -6. Replacing it with 0, we get -3. Replacing it with 1, we get -2. And this is my vertex, so this is my turning point. So what I should see are my x values repeating in the opposite direction. So when we substitute in 2, we get -3. And make sure you're substituting it into both x values. When we substitute in 3, you get -6. And 4, -11. So we're going to graph all of these points. So starting with my vertex, 1, -2, 0, -3, -1, -6, and -2, -11. That's going to come off our graph just a little bit. Then on the other side of our parabola, 2, -3, 3, -6, and 4, -11. And then we'll connect it. And we can see, so remember we're talking about our roots. We're talking about where it crosses our x-axis. So we can see our x-axis here, and our parabola does not cross it at all. So don't be tempted to say, oh, it crosses right here. That's where it crosses the y-axis. And we're talking about where it crosses the x-axis. So the way we're going to write this, over on the left, it's going to be x equals still. We're going to use our bracket. There's nowhere where it crosses. So we leave that bracket, we leave that set empty. So just like we wrote our answer for number 1, just with no numbers within the brackets. You can also write it with our no solution symbol. On the next page, if you'll highlight numbers 4, 5, and 6, you're going to be doing this same thing. Remember, if you don't have an A, B, and C, if one of those pieces is missing, we use 0 to represent that number. So you're going to need to remember that for number 5 and number 6. Now let's talk about one more thing when we're talking about roots, and that's called our discriminant. So the discriminant can be used to help you determine the number of solutions. So it's a formula that is used to determine the number of solutions. So sometimes you might not have to know exactly what the solution is. So we found those solutions when we were graphing a minute ago. Sometimes you just need to know how many you have. So remember, at the very beginning, when I drew the 3 graphs, you could have 2 solutions, you could have 1 solution, or you could have no solutions. So that's what we're going to be looking at, is determining, is it 2, 1, or none. The formula we use for that is b squared minus 4ac. And again, we find A, B, and C from that standard form. So we still are going to be identifying what's A, what's B, and what's C so that we can use it. Now, when you find this is going to tell you what D equals. If D is greater than 0, that means that you have 2 solutions. Now, this isn't going to tell you what those 2 solutions are, but you know your parabola is going to pass through your x-axis in 2 spots. If D is equal to 0, that means you have 1 solution. So your parabola is only going to touch the x-axis in 1 spot. And then if D is less than 0, there are no solutions. It doesn't cross your x-axis at all. And again, this doesn't tell us specifically what the solutions are, just how many solutions we have. So let's just look at a couple of examples using this. So our directions over here tell us to use the discriminant to determine the number of solutions. So we're going to identify A is 1, B is 5, and C is 4. And then we're going to use the formula b squared minus 4ac. And we're just going to replace all of our variables with the values, remembering to put them in parentheses when we replace them. So instead of b, we're going to replace b with 5. So 5 squared. Minus 4, instead of a, we know that a is 1. Instead of c, we're going to replace that with 4. And then we just solve this. We know 5 squared is 25, minus 4 times 1 is 4, and 4 times 4 is 16. And 25 minus 16 is 9. So now that we have 9, we want to compare that to 0. We want to know, is 9 less than, greater than, or equal to 0? Well, we know that 9 is greater than 0. And because it's greater than 0, we know that we have 2 solutions. We don't know what those 2 solutions are. If we needed to, we could figure that out. But we know that this function has 2 solutions. Go ahead and highlight 8 through 12. And remember, with discriminant, you really only have 3 answers you're going for. 2 solutions, 1 solution, or no solution.